So today we'll discuss about chromatography. So chromatography, it is a technique for separation, purification and testing of compounds, or you can say proteins. So here we separate and purify compounds, proteins. So then we have types of chromatography. It is 4 types. First we have adsorption chromatography. Then we have thin layer chromatography. Then we have column chromatography. Then partition chromatography. So now number 1, that is adsorption chromatography. Now here separation is based on adsorption. Now here we have a stationary phase, that is solid state, and here the gas or liquid components, they will get adsorbed here. Not absorb, adsorb. So here we have liquid extraction. Then here stationary phase, that is solid state. Okay, after that there is thin layer chromatography. So in thin layer chromatography we have 2 phases, stationary phase and mobile phase. So stationary phase, that is thin layer of cells. So that is basically silica gel or alumina. Then we have mobile phase, that is solvent. So here we use capillary action. Capillary action is when you suck a let's say a fruit juice through a pipe, right? That liquid that flows through the pipe, that is basically capillary action. That movement from bottle to through the pipe, that is capillary action. Okay, next we have then third is column chromatography. So column chromatography, it has further 3 subtypes. First is gel filtration chromatography. So gel filtration, that is also called permeation chromatography. Permeation chromatography, and sometimes also size exclusion chromatography, because it's based on size. Okay, then second we have ion exchange chromatography. Then third is affinity chromatography. Okay, so coming to first, so now gel filtration chromatography. What happens here, we have pores, or you can say beads. Now the it is somewhat like this. So here we have mobile phase as well as stationary phase. So now point at which different components of the compound stop moving and separate from other components. At that point, separation is based on different molecular size. Now let's say here if I need to check out molecular size, elution order. Elution order means which molecule moves first, like this, like I have three molecules of different sizes, this one and this is the smallest one. Okay, so elution order means which will move first. Okay, so now if I start from the smallest molecule, now let's say this is the smallest molecule. So the smallest molecule, it will enter pores of gel. So now this is the smallest molecule, so it will enter pores of gel and it will move slow. And if I take the largest molecule, let's say this is the largest molecule, so this molecule that is too large to get trapped inside the pores, or you can say stationary phase. So this stationary phase is basically pores only. So now this large molecule, it's see the size of this this square. This is too small. This molecule is too big, so it cannot get trapped. It will not enter the molecule, so it will move easily. So this will move fast. So the elution order will be like the biggest, largest molecule, then a medium one, and at last the smallest one. Okay, so then we have after gel filtration, under column chromatography only, we have ion exchange chromatography. This comes under column chromatography only. So now ion exchange, as you know, we have two types of ions, cations and anions. Cations are the positive one and anions are negative one. So here chromatography that is based on the charges. So now how it occurs is, let's start with cation. So here in cation we have the stationary phase, that is agarose. So stationary phase is agarose, and so stationary basically it's made up of cellulose, agarose, so it is solid one. So stationary is basically solid and mobile is liquid. So here let's say in cationic, agarose, we take it as agarose is X. So X A negative plus, because we are talking about cationic, let's say B positive. So now this is now this X is agarose, this A negative, this is the anion. Now B positive, this is present in molecule. So this anion, this is blocked by B, or you can say blocked by cation. So XA, this whole is our stationary phase. X is agarose. Okay, agarose comes under stationary phase. So now so stationary phase is fixed. Now the structure is like this. Here we have D negative, C positive. This is present in molecule itself. So now what will be the reaction? See what will come out. If I see, this will be like this: X A negative plus C positive. So we will, this will be X A negative plus C positive, sorry, A negative. So now why, because since it's negative, it will choose the positive one, negative positive attraction. So it A negative and C positive. So here now this D negative, this is present in molecule. So now what will come out? The negative molecules will come out, negative or as well as neutral also. So D negative and B positive will be eluted out. Now we have to what will be eluted out means what will come out? D negative and B positive. See, we were talking about cationic, means cations, so we will check the positive sign. So positive is getting this, we need this is eluted out, B positive. Similarly in anionic also this will be vice versa. Anionic ion exchange chromatography. So here first we need to look out for stationary phase. Stationary phase is resin. This is positive. Since we are talking about an ionic, an anion is negative and the stationary phase will be opposite. Okay, now X A positive, A and A positive, this is cation and this whole is the stationary phase, this is fixed, plus B negative. Similarly in the column it is D negative and C positive that is present. Now what will the reaction will be? Somewhat like this: X A positive plus D negative. Since it's positive, it will get attracted towards the negative sign. So now what will come out? A positive and D negative. So here what will be eluted out? Positive as well as neutral. So for this is now A positive and D positive, this is getting, this is coming here, so we are left with C positive and this B negative. So our main purpose was to elute this C positive, so it is getting eluted. So here our aim was to isolate C positive. Okay, after that we have next type of chromatography, that is affinity chromatography. It is most common method for purifying recombinant proteins. So affinity chromatography, that is basically So this comes under column chromatography. Column chromatography sometimes also called gravitational force also, in other words. So affinity chromatography, what happens, this is, let's say there is a diseased person, right? So we will take antigen of that disease. Okay, it will react to that antibody. So here stationary phase is agarose, mobile phase is aqueous liquid, and the stationary phase gets attached with nickel or cobalt, and they will further get they combine with histidine. So this way this affinity chromatography works. Here we just talk about the little bit introduction. Okay, at last we have partition chromatography. Partition chromatography, here we have two liquid phases. And separation that is based on partition. So here we have liquid solid extraction, then stationary phase we have liquid state. So partition chromatography, here we have liquid chromatography, and then we have gas liquid chromatography. First there is liquid, then there is gas liquid. In gas liquid chromatography there is GLPC that is based on partition, and along with GLPC also called vapor phase chromatography. Okay, so this is about the types of chromatography. So chromatography, that is of four types: adsorption, thin layer, column, and partition. So in column chromatography we have further three types: gel filtration, ion exchange, and affinity. And in partition there is liquid chromatography and gas liquid chromatography. Okay, so that was all for today. Thank you.